Hello, App.js conference. It's great to be back here in Krakow on stage again. My name is Kiryl. I'm a software engineer from Margelo, and last year I gave a talk about keyboard management evolution. This year we are switching gears a bit. The topic is called illusion of portals. I'm pretty sure most of you already know what a portal is and when to use it, but just out of curiosity, could you raise your hand if you ever needed to use it in your app? Okay, many of us, great. Before we dive into deeper internals, I would like to take a moment and quickly recap what a portal is and when would you use it. We also have people watching us online, so it's important to be on the same page. Let's start our journey with a simple question. What is a portal? At a high level, portal is a mechanism that helps you to render part of your component tree somewhere else. Why is that useful? Let's imagine you have a logout button. When user press it, you want to show a confirmation dialog. Now, obviously, you cannot just render it in the same component because you expect it to cover the entire screen. So it needs to be rendered above everything at a higher level where it can actually overlay it. And that's exactly where portals comes into play. For rendering a portal, we need to explicitly use the create portal function. And the frustrating part is that it doesn't come from React core package. You need to import it from React DOM. So in practice, this concept is really tied to the web. On mobile, though, we often need the same idea. Render something outside of the current component tree at a global level. Interestingly, but many React Native developers don't really think in terms of portals at all. Why is that? First, as mentioned, the portal concept originates from web development, so it's not part of the mental model in React Native. But there is a more important reason. In React Native, we already have a component for this problem. This is the model component. You can render it anywhere from your component tree, and it still will appear on top of everything else. So, in a way, React Native already gives you a portal-like behavior. But it's important to understand that model only partially implements the idea of portal. On the web, portal gives us full flexibility in deciding where exactly the content should be placed. You can attach it directly to body, or you can target any other element in the tree. And this is the key difference. It doesn't just mean render on top of everything. It means you can choose the scope of that rendering. For example, imagine building a context menu. You might want it to be visually rendered above a specific screen, but still behave as part of the screen, so that when you swipe it away, the context menu moves along with it. And in model, it's kind of not achievable. Your component will stay on the screen where it is, and it will not follow your screen. So it's not just about layering. It's about a control over where things live in the tree. And in that sense, model is just one specific use case of what portals can do. It solves a very basic scenario, but it doesn't cover the full spectrum. And this actually proves an important point. We do need portals in mobile as well. So the question becomes, what do we actually have? In fact, React Native ecosystem has already several solutions. And all of them solve a problem in a fairly similar way. So let's take a look at their API and the difference between web and React Native. On web, create portal function accepts two arguments: the content that we want to render and the target DOM element, where that content should appear. In React Native, historically, we didn't have an API like getElementById or any other way to directly query arbitrary nodes. So the API evolved a little bit differently. Instead of imperative approach, the API converged on a declarative model. First of all, we need to define a portal host. You can think of it as an anchor point or the destination where the content should be rendered. Then, somewhere else in the tree, we need to render a portal component and target a specific host through something like a hostname prop. All children inside that portal will then appear under the corresponding portal host. So at a high level, everything feels very React-like. We declaratively described what should be rendered and where it should end up, but still within the constraints of the React framework, not the renderer implementation. But let's quickly look under the hood of these implementations to see how they actually made and how they differ from the web. As I mentioned earlier, most portal solutions implemented in JavaScript are purely in JavaScript. The common pattern is to use some kind of shared state, typically React context, Ziusko, or any similar store, to keep a global registry. This registry is a simple key-value map, where the key is the host name and the value is data associated with that host. When portal host mounts, it registered itself in this map. Later, when a portal is rendered, it pushes its children into the same shared state under the corresponding host name. The matching portal host receives that content and renders it in its own place. And to be clear, this idea is not bad at all. It actually pushed ecosystem forward in a meaningful way. It powers many popular libraries like React Native bottom sheet. But at the same time, it's important to understand that this approach is fundamentally different from how portals work on web. Let's take a look at a simple example. We have a component that renders two children, A and B, but B is rendered through a portal. Now, if we inspect it in a React DevTools, we will see a logical React tree, the one on the right side. The app is a parent and it has two children, A and B. Even though B is rendered somewhere else in the actual UI through a portal, it still appears as a direct child of app component. Now, if you switch it into React DevTools, we will see a slightly different picture. There will be a div block with ID root. That's where React's entire app is mounted. App will be attached to this root element. And because we are using a portal, component B will also be attached there, effectively rendered into a different DOM node. So everything works exactly as expected. But if we try to run the same code in React Native, we will immediately see a difference. The native hierarchy output will look correct. So from a rendering perspective, it looks like a portal. It behaves like a portal. It takes content defined in one place in JSX and renders it somewhere else. So visually, everything works as expected. But what about React tree? In reality, it will look identical to native tree. Why does it happen? Because we are effectively modifying the React tree by rendering children in a different part of it. In other words, our JavaScript implementation is physically changing where in the tree certain elements are mounted. And this approach comes with its own cost. Once you start modifying tree like this, some core React features begin to break or behave unexpectedly. The common scenario is context propagation. Imagine this layout. B is rendered through a portal while C stays inside the context provider. Because JavaScript portals physically change the place where elements are rendered, B is rendered now outside of that context, which means it simply cannot access it anymore. A common workaround is to move provider higher up, and sometimes it works, but not always. Especially when you need multiple providers stacked on top of each other, each with its own value. And that's where things starts to break. We are trying to preserve React's model while reshaping the structure of tree and runtime. So, on the surface, it looks very similar to Portal. But it isn't really portals. It's more like a simulation, an approximation, an illusion. And this is exactly where the title of this talk comes from, the illusion of portals. All these solutions give us something that looks like a portal, feels like a portal, but behaves differently where it actually matters. And that difference is not just theoretical. It affects how your state flows, how your app scales, how predictable your UI really is. So, at some point of time, you start to realize this is not about missing an API. This is about missing a primitive. And once you see it like this, the question changes. It's no longer which portal library should I use. It becomes why don't we have real portals in React Native at all? And exactly that question led to the creation of React Native Teleport. Not as another variation of the same idea, but as an attempt to fix a root problem, to combine a declarative API, something that feels natural in React, without breaking React rules and avoiding tree reshaping at runtime. And to achieve that, we took familiar mental model from React Native, where portal and portal host are declarative components, but moved the actual rendering responsibility down to the native layer. So, in one sentence, in this model, React keeps the ownership and native use handles the placement. And portal host are no longer just pure JavaScript components. They render native use, and this native use becomes responsible for managing and attaching children, which is much closer to how create portal function works on web. But with this approach, we still have a clean, isomorphic React abstraction that works on all platforms while using native primitives under the hood. But there is a reason it's called React Native Teleport, not a React Native portal. So let's draw a line here. We've talked what portals are and what we have in React Native. Now let's go one level deeper, because once you start thinking and working with portals, a natural question comes up. If we can keep content in one place in the tree but render it somewhere else, can we actually move an existing element between different containers? And the short answer is no, not in a React world. React Reconciler has strict rules, and it doesn't really support moving an existing element between different parents. From its perspective, the move operation doesn't exist. Even if you try to preserve an element identity with a stable key, once you attach it to a new parent, React will treat it as something new. Internally, it's effectively delete and create operation. Unmount from one place and mount again in another. So in React world, nothing is ever truly moved. It's always recreated. And this is not just an internal implementation detail. When you remount heavy views, like high-resolution image, videos, maps, or other complex elements, you often notice a flicker. Because every time the element is recreated, it needs time and resources to initialize everything again. But here's where things get interesting. In Teleport, we've pushed this responsibility down to the native layer. And once views are no longer managed by React, everything changes. We are no longer limited by the idea that moving is impossible. We can actually take an existing native view and attach it somewhere else in the hierarchy, without destroying it, without recreating, without losing its state. We just move it. And this technique is called reparenting. This is the moment where the mental model of React quietly breaks, because what React says is impossible suddenly becomes possible at the native level. And I know that at this point you might ask, okay, so now effectively we have a force operations in React. Instead of just create, update, and delete, we also have move operation. So what is the point of it? At first glance, it might feel unnecessary. After all, we always can unmount a view from one place and mount it again in another. But when you start thinking about it more carefully, you realize something important. This missing primitive, moving instead of recreating, actually opens a whole set of new capabilities that are very hard to achieve otherwise. So let's explore them. We can take the Instagram app as an example. When you press on a video, it feels very natural. The video smoothly scales up and transitions to a next screen. The transition is fluid, continuous, and you never lose a context. On Android, it works differently. When you tap a video, you might see a preview frame or even a black screen. And only when transition completes, the video playback will resume. So effectively, continuity is broken. But now let's see how we can implement this kind of transitions using Teleport. And with Teleport, we get the same seamless transitions on iOS, Android, and even on web. This works because we are effectively moving the video between different containers, not recreating it. So our playback is never interrupted. And now, just think about it for a second. With help of React Native, we can build applications faster, thanks to a shared code base which can be run on multiple platforms without any changes. But now, we can deliver an experience that feels sometimes even more polished than native. Isn't it cool? I think it is. Another area where this kind of capability really shines is context menus. We can take the Telegram application as a reference. On iOS, there is a really beautiful interaction pattern. When you long press an item, it gets lifted above everything else, the background gets blurred, and your focus is entirely on the element and its available actions. There is no distraction. You immediately understand what you are interacting with. Now, if you look at the same pattern on on Android and web, you will immediately notice the difference. The selected element just gets covered by a context menu. And as a result, it's not always obvious which item was actually selected. So the connection between the action and the element becomes weaker. And from a UX perspective, iOS handles this much better. With help of Teleport, we can literally take the selected element, lift it above everything else, preserve its state, and create consistent high-quality experience everywhere. iOS, Android, and web. And for us, that means that users don't have to relearn interactions depending on the platform. They know what to expect. And we can deliver, as developers, the same level of polished, exceptional UI across the board. And at this point of time, you might be thinking, wait, didn't we see something like this in the documentation already? And you'd be right. The React team on web introduced support for view transitions, which makes it much easier to build such kind of interactions. But there is few important things to keep in mind. First, view transitions are only browser API. There is no direct equivalent in React Native yet. Second, view transitions are mostly about animations and transitions, whereas Teleport is about moving an element between different containers without animation. If you want to make it animated, you need to use additional library. And last, but probably the most important, is that view transitions rely on a snapshot-based approach. So when an element appears in a different place in the tree, browser doesn't actually move a live element. It takes a snapshot and animates it instead. And it has consequences. If you try to recreate some of the demos we just talked about, you will notice that as soon as transition starts, the content freezes. And when transition ends, the video effectively resets in a way that breaks continuity. So while both approaches are trying to solve a similar problem, they are fundamentally different. View transitions rely on browser API and snapshot-based approach, whereas Teleport works with the actual live content, preserving state, preserving continue, and enables truly seamless transitions. And Teleport and this library can be used for many other advanced UI interactions. Things like app tours, where you highlight a specific element, dim everything else, and bring that element up front of the screen. An image gallery, where selected photo seamlessly scales into a full screen view. Pick and pop interactions, where long pressing an item reveals a preview of the next screen before navigating it. There is also many use cases in chat applications. For example, sending a message, where a text from the input smoothly transforms into a message bubble. PDF attachments, previews, maps, where the card smoothly expands into a full screen view without flickering. Animated stickers previews, where the sticker can be moved into preview area without restarting its animation or flickering in any way. And many, many more other use cases. And the really exciting part is that the same code works everywhere. We are no longer stuck thinking, well, this is iOS-only API, so Android and web will not get the same experience. With help of Teleport, we can deliver the same transitions and result to all platforms. And as I said before, Teleport is not only about animations and transitions. Another area where it can be really useful is component preloading. We can render heavy components off-screen ahead of time, keep them mounted and ready, and then simply teleport them into a screen when it opens. And instead of creating everything at the moment of the navigation, we can prepare the UI in advance and make transitions feel almost instant. I know you might be confused because of the word off-screen. After all, the off-screen was the former name of the new React activity component, and both approaches are trying to improve perceived performance. But the difference is pretty fundamental. React activity keeps an existing part of UI alive, while making it hidden and lower priority. The component stays exactly where it is in the React tree. React preserves its state, but can deprioritize its update while it's not visible. So the component still exists. It's just hidden and inactive. Teleport works differently. Instead of keeping a component hidden in the same place, we can render it somewhere else in the UI hierarchy, keep it mounted and ready, and then simply move it on screen when we need it. So, one approach is about preserving UI while it's inactive. The other is about relocating live UI between different elements. And I think that's everything that I wanted to share for today. Let's quickly summarize the main ideas before we wrap up. So, what did we learn today? We started with simple portals. Something that sounds familiar, something many of us already used. But when we look deeper, we realized that in React Native, most portal solutions give us only the appearance of portals. They look visually right, but they change the React tree, they affect the context, they reshape the mental model we rely on. And that's the illusion. Teleport tries to break that illusion by moving responsibility rendering to the native layer. In this model, React keeps the original tree untouched, and native views handles the placement. And from there, we can do something that React normally cannot express. Move existing UI. Not recreate it, not remount, not reset it, just move it. This gives us smoother transitions, better continuity, and most important, a new way to think about advanced cross-platform UI. Because sometimes, when interactions feel impossible, the answer is not to fight React and not to try to copy a single API from one platform and leave others behind. The answer is to look one level lower and find the missing primitive that all platforms can share. And for us, this primitive is moving UI. That's the idea behind Teleport. But I also don't think this is the end of the story. The patterns that I showed you today are only a starting point. I'm sure there are many more other interactions, use cases, ideas, and maybe even completely new libraries that can be built on top of it. So my hope is that you leave this talk not just knowing about Teleport, but with a slightly different mental model for the how UI can be built. Because once we find the right primitive, the most interesting part is what people can build on top of it. Thank you for your attention.